So my portion of our STEAM lesson with math, science, and music has to do with incorporating music into math and science. So I described how sound is produced, how it is caused through vibrations in the air and the displacement of air, and related that to amplitude, which is volume in decibels, and then the wavelengths that are how we measure sound, and frequency, which is the measure of how high a pitch or how low a pitch is. And so this was to kind of introduce music in a new light. Instead of just being arts, I can bring in the science and the math foundation and elements to it.
Hi, Matthew. Today in class, we're going to be learning about how we hear sound in regards to the ear to supplement the math and music portion of our lesson. So pretty much what I'm going to explain is how the human ear can detect different frequencies of sound, high and low, and how we can differentiate between volume. And I'll also be talking about different parts of the ear and how they differ from each other.
Okay, so today in class, we're learning about frequency, amplitude, period, and what a wavelength looks like. Frequency is the measurement of how many cycles there are in a given period. And a period it's known as a cycle. So basically it's really a measurement of distance on a wavelength. And the wavelength is the actual wave visually shown on a graph. All right, so the next step we're gonna do, we're gonna get into our groups, and then we're gonna,
Do you want to be my partner?
Yeah, let's do it.
all right, cool. So now that you guys found your groups, let's go ahead and begin the assignment, okay? The activity. So what are you guys doing over here?
We're gonna label these two, right?
Yeah,
Right? That's
I
what he
think
said.
so.
Okay.
So I think we're supposed to draw them out.
Okay.
Go.
Hi, Monse. All right, so tomorrow we're going to be learning about wavelengths, and I wanted to get you some information that you can look over tomorrow or tonight, so that way you kind of have an idea of what we're going to be going over tomorrow. Okay. So what we're going to do here, these are going to be some definitions, and then we're going to draw some examples. So the lesson we're going to learn today is about wavelengths. All right, let's see. Good job. All right, so what is a wavelength? What do you guys think a wavelength is? Monse?
I don't know.
You don't know? All right, Monse. We're gonna use some definitions in English, and you can feel free to use this to translate, okay, in Spanish, and put your own descriptions in your language, okay? All right.
science, we have the use of math. And in math, we have the use of language, since we do have word problems and reading. In music, we use a lot of science, and sometimes we use math as well. So right now, we're going to talk about music. So we have sounds here through music. We have low pitches, high pitches. We can also play quiet sounds and loud sounds. So the way sound is produced is through the vibrations in the air. So the air is displaced, the air molecules are displaced through the vibrations of whatever you're playing through. So it could be singing, it could be a stringed instrument, it could be a piano, they all do the same thing. So on this instrument, you can physically see the vibrations in all the strings. So without the strings moving, you do not have the displacement of the air, and there'd be no sound. So without air, there wouldn't be any sound either. So we have these bigger strings that produce our low sounds over here. Then further, we have these skinnier strings that produce our higher pitches. And so just like we have high and low, we also have loud and we have soft sounds. All right, so now that we know we have low and high and soft and loud, we can also combine them. So we can always play a low quiet sound, just like we can play a low loud sound. Same goes with the high. You can do louder and you can do softer. Just like when people speak, sometimes you hear a really low voice that can be really loud. Sometimes you hear a high voice that's really quiet. So that can all combine. And so when we have these high pitches, they're also known to have a high frequency, which in science we measure them with hertz. And then for low ones, still hertz, just gonna have a different numerical value. And so the way we measure volume is a little different. We have these things called decibels. So the higher the volume, the bigger the number is gonna be. Just like when something is quieter, the smaller the number is gonna be as well. So the next thing we're gonna talk about is how our ears perceive these sounds.
So you guys might be wondering how we hear. Here I have a diagram of the human ear. The human ear is made up of three parts. You have the outer ear, the middle ear, and the middle ear. The outer ear is made up of your earlobe and your ear canal. The middle ear is made up of these three bones, and the inner ear is made of the cochlea and your auditory nerve. So pretty much what happens as you hear a sound wave, it's going to be directed into your outer ear, and your outer ear is going to funnel it and direct it into your ear canal. The ear canal is from the ear canal, it's going to move and vibrate the eardrum, like this. These vibrations are going to be translated into the middle ear, into these small bones, the malleus, the incus, and the stapes. These small bones will transfer the information to the cochlea. In the cochlea, we have a liquid, and inside the cochlea, we have something that's called the basilar membrane. As the liquid vibrates, it's going to hit these hairs in the basilar membrane, and they're going to bend. And when they bend, they transfer a signal into the auditory nerve. So that's how we hear sound. But you may be thinking, how about frequency when it changes? When you have a higher frequency, it's going to be transmitted on the outer cochlea, the snail portion, like a loud scream, high-pitched scream. When you have a low pitch, like a dog barking, it's going to be on the inner part of the cochlea, up here. Now you may be thinking, how about volume? Volume is translated in terms of how rigorous the basilar membrane inside the cochlea vibrates. If you have a loud volume, it's going to vibrate more vigorously. If you have a low volume, it's going to vibrate. Now that we learned a little bit about what sound is and how the human ear processes sound information, you might be like, so what about the math part? Well, with math, we can use waveform to analyze the sound and what happens in terms of frequency and decibels.
Now that we know how sound travels in air molecules, or air, and how the ear processes it, now we're going to take that data and make it tangible. And the way we do that is by utilizing wavelengths visually. So wavelengths, they have three components that we're going to talk about today, which is the period, which is really just another word for time. Frequency, which is measured in hertz, it's cycles per second, and it also shows on both of these graphs. One is a low frequency, and you can see the peaks and the valleys are far in between. And in the high frequency, they're more condensed. And that's what we're referring to as frequency. Amplitude is how high those peaks are. And what we're really concerned about in this lesson today is the realization that even if we have the same amplitude, even if these peaks meet at the same spot, they can still have a different frequency. And this is this is what that would sound like again with sound. Low frequency would be, and a high frequency would sound like this. All right, so the next step we're gonna do, we're gonna get into our groups, and then we're gonna,
Do you want to be my partner?
Yeah, let's do it.
all right, cool. So now that you guys found your groups, let's go ahead and begin the assignment, okay? The activity. So what are you guys doing over here?
We're gonna label these two, right?
Yeah,
Right? That's
I
what he
think
said.
so.
Okay.
So I think we're supposed to draw them out.
Okay.
First.
What are these arrows meaning?
I forgot.
Oh, cycle.
Cycle.
Cycle. The arrows are the cycle. Okay. So then these would be the cycle.
I see. From here to here.
Mm-hmm.
Okay.
And then that's one cycle.
Mm-hmm.
We'll just put one. What else? This is low frequency?
No, I think this is high frequency because it was high. You know?
Are you sure?
No.
No?
Hey guys, okay, so how are you guys doing?
Doing
Is
okay.
this low frequency or high frequency?
Oh, okay. So actually, when it's spaced out more, this is going to be considered a low frequency, okay?
Okay.
Oh, I remember that.
Okay. So this one's low, and this one's really skinny. So this one's the high frequency.
Yep, that's right.
Oh, I remember.
Okay. Okay. What else are we missing? Amplitude.
Amplitude. That's how high it goes.
That's
to,
how high it goes.
to the peak, right?
Yeah, that's what it says right over here. It goes up to the peak from our 0 line. So here is amplitude.
All right, how are the groups doing? Are you guys almost done?
Yeah, I think so.
Yeah, show of hands.
Mm,
All right, cool. I'll give you guys another minute or so.
Okay, so we know this is the 0 line, and the peak is the tip, right?
Yes.
That's the peak,
Yeah, it's not the bottom.
not the bottom. Okay, so then this spot is peak.
You guys almost done?
I think so.
Yeah, I think we have
Okay.
to label
I think
The bottom
the
one,
cycle for this one.
Right? Okay.
So let me try it out. So I think it goes from here to here. Is that right, Mr. Vega?
no, Matt. Actually, when is the next point where this is going up like that?
Oh,
Right
it's
here?
right
The second one?
here.
That's it. So that's one cycle.
Oh, it's not the whole graph. It's just the next loop.
Good job. All right. Okay, let's start getting ready to put our stuff away, okay?
Okay.
Okay. Go.
Hi, Monse. Alright, so tomorrow we're going to be learning about wavelengths, and I wanted to get you some information that you can look over tomorrow or tonight. So that way you kind of have an idea of what we're going to be going over tomorrow, okay? So what we're going to do here, these are going to be some definitions, and then we're going to draw some examples. The first definition is frequency, so it's Frequency, and that is the measurement of how many cycles for a given period. And you can think of cycles of like how many times it repeats itself. So what we're going to be looking at are some wavelengths, and I'll just show you really quick. So from this point going up until it goes back up the same way is one cycle, okay?
Okay.
So, and these are measured in hertz.
Hertz?
Yeah, hertz, Hertz. And the symbol is Hz. Okay, and why don't we put the symbols right here? So, yeah, good job. So the frequency, it's going to be a lowercase f, and then hertz, we just said was Hz. Okay. All right. So let's go ahead and draw an example of frequency. Okay. So the first one I want you to do is you're going to draw a straight line, and then we're going to do a low frequency. So a low frequency has a larger gap between each cycle. Okay, so you see how it's like spaced out more?
Mm-hmm.
Okay, good. And then that one we'll label low frequency. Good job. And now we're going to do a high frequency. So let's do it again. So it's going to be a line. And instead of being spaced out, we're going to bring it in tighter. So you're going to, yep, just like that. Good. Good job. And we'll label that one high frequency. All right. The next word we're going to write is amplitude. And this is how high the peak is in a wavelength. All right. This measures volume. And it's measured in decibels. That's D-E-C-I-B-E-L. Good job. And the symbol for decibel is lowercase d and uppercase B. Good job. All right. And the symbol for amplitude is a lowercase m. Okay? All right. So let's go ahead and draw again another wavelength. So I already drew one right here, so you can go ahead and do the same thing. Good. And the amplitude is how high to the peak, right? So we're going to start from 0. We're going to make an arrow just to show that that's the amplitude. So if that's the amplitude, this one is also the amplitude. Okay? And that's it. Good job.
Students don't really talk about.
All right, kids. All right, class. We're gonna start our lesson
with cheese, pepperoni.
Matt. Let's pay attention, all right? Okay, so the lesson we're gonna learn today is about wavelengths. All right, let's see. Good job. All right, so what is a wavelength? What do you guys think a wavelength is? Monse?
I don't know.
You don't know? Okay, so hey Matthew, why don't we go ahead and sit up here in the front with me? Like right here at the front so you can see the wall, the board. All right, cool. Okay, so up here on the board, I'm gonna be drawing what a wavelength looks like. And what we're gonna do today is we're gonna label that, okay? So, all right, everybody draw the straight line like this. Good job. All right, good. All right, now you're gonna do, it's gonna look like a squiggly line right now, but it's gonna make more sense after. We're gonna do this, okay? All right, good. Okay, so actually, Matt, the line is gonna go straight through. There you go, yeah. Good. All right, so what we're gonna do now is we're gonna write the different properties of the wavelength, okay? So from amplitude of a wavelength is from the straight line that you drew, straight up to the peak. Okay, good job. And let's label that amplitude. Good. You got it, Monse? All right. And then the next thing we're gonna do is show an example of what a cycle is, okay? So why don't you draw, good job, a straight line just like that. And then draw another wave, just like that, good. Okay, so what we're gonna do is you're gonna point an arrow straight up from that first line of your wave. We're following the direction. Okay, and then, here, let me show you, Matt. And then what you're gonna do is another line from right there. Good. And that's considered your cycle, which is from the same exact point as it's repeating, that's considered one cycle, okay? So you can do really a cycle from each peak. You could do a cycle from where it meets at the straight line, okay? All of those could be considered cycles as long as it's the equal distance between each repetitive line, okay? Good. All right, so all right, Monse. We're gonna use some definitions in English, and you can feel free to use this to translate, okay, in Spanish, and put your own descriptions in your language, okay? All right. So what we're learning right now is about frequency. So this is the measurement to how many cycles for a given period. Okay, good. So it's a measurement and then put period, circle period. Okay, and good. So you have this, and here is a visual of what that looks like. Okay, so what this means is that this graph right, or this wavelength right here, is a low frequency. And this one, it's a frequency, but it's high. Good job. Okay, do you understand?
I think.
Yeah? Okay. So if you need to write more, okay.
Okay.
All right.
This one.
good job. Okay, the next thing we're gonna learn about is amplitude. You might want to look up that word.
Creo que es lo mismo. Amplitud.
Okay, and that is how high the peaks are in a wavelength.
High.
High. Okay,
Peaks.
peaks. So a peak is the top piece, the top of the wave. Yep, that's it. Peak.
Okay.
Okay.
Peak. Oh. Pico.
Okay. All right. So how high the peaks are in the wavelength. Okay.
Wait.
Wavelength. Yeah. All right. And this is a wavelength. All of this. All right.
Okay.
Good job. Okay. The way we symbolize amplitude is with an M. That's a symbol. And this is how we measure it, is with a decibel. Okay? dB.
Okay.
Okay? Good
Es
job.
lo mismo.
Mm-hmm.